Question 1 gives us the diagram of a pyramid with a vertex V and a rectangular base. We're being asked to find the length of one of the sides, which you will be able to see is quite straightforward to do with Pythagoras' theorem, and asking us to find the angle at the vertex. Again, this will be quite straightforward using the cosine rule, so let's see how it's done. So how do we find the length of the side BV? Well, if we consider a 2D case, where on a coordinate plane we've got 2 points A and B, and if we go from A to B, following the x and y axis, so we go across A 4 points and then up y 3 points, you can see that lo and behold we have a right angle triangle, and so actually the distance between A and B is simply Pythagoras' theorem, that we can use the distance d to be the difference in x squared plus the difference in y squared, and then take the square root of that. For the three-dimensional case, it's exactly the same, except that we just add in the z component as well. So Pythagoras' theorem is used to find distances in coordinate geometry. In order to find BV, we're just going to do Pythagoras' theorem. So we've got BV is equal to the square root of the distance between the x's squared plus the distance from the y's squared plus the distance from the z squared. Now you can throw all of this into your calculator and you'll eventually come out with an answer BV is equal to 10.2956. And just don't forget that in the IB exams, the default is to answer to 3 significant figures. So for us, that's BV is equal to 10.3. In order to answer part B of the question, we're going to use the cosine rule, which is a way of linking sides of a triangle to angles of a triangle. Where it comes from is if we take any triangle, we can always add a line that breaks up one of the angles and splits it up into 2 right-angled triangles. We can see then that the base ends up being x and c minus x. We can then do some trigonometry on both sides of the triangle and link them together in order to get a formula that combines sides and angles. From the left-hand side of the triangle, we can see that the cosine of A, so the cosine of the angle, is x all over b. Rearranging that, that's x is equal to b cosine A. Then c minus x is simply c minus what we just solved for x, so c minus b cosine A. We can do the same with sine, that the sine of A is equal to h over b, therefore h is equal to b sine A. Then looking at the right hand side of the triangle, we can do Pythagoras' theorem that a squared is equal to h squared plus c minus x all to be squared. However, we have just created new terms for h and c minus x. So substituting that in, we have that a squared is equal to b squared sine squared a plus c minus b cosine a all to be squared. Multiplying that out, we've got a squared is equal to b squared sine squared a plus c squared minus 2bc cosine a plus b squared cosine squared a. Factorizing out b squared from 2 of the terms, we have a squared is equal to b squared times by the sine squared of a plus the cosine squared of a plus c squared minus 2bc cosine a. Sine squared of a plus cosine squared of a is equal to 1. So we end up with our formula a squared is equal to b squared plus c squared minus 2bc cosine of a. And then we can use this formula to solve for an angle. Finally, to answer part B, there's a couple of things you need to recognize first. First of all, that the line BV, which we have solved for, is also equal to the line VC, and the base BC is equal to 8. Then, using the cosine rule that c squared equals a squared plus b squared minus 2ab cosine of theta, we rearrange for the cosine that we want. So we've got the cosine of the angle BVC is equal to BV squared plus VC squared minus BC squared all over 2BV times VC. Filling in some numbers for that, we have that that's 10.3 squared plus 10.3 squared minus 8 squared divided by 2 times 10.3 times 10.3. Plugging that into your calculator, you can see that the cosine of the angle is equal to 0.6983. And finally, taking the inverse cosine of that, we get an angle of 0.798. This is in radians, and you should mark it that it is in radians. Thank you so much for watching. I hope this tutorial made things clearer and helped you tackle this question. Don't forget to like, subscribe, and hit the bell to stay updated when more questions are answered. If you have any questions or need any more help, please drop a comment below and I will get back to you. Until next time, keep practicing and good luck.